saw when you combine what the RTG puts out and kind of an energy balance with depleting the battery and recharging it completely. Now, once we start to characterize the system, we will potentially, move that number up a little bit, but that's our constraint, and so you have to plan things. So you can stay up in the middle of the night, and you can be up for a few hours, but you still have to stay within your 2,000 watt-hour constraint. Yeah.
Okay, Craig, you had a question? And then we're going across the aisle. Yep.
Hi, Craig Cavalt with America Space. I think for Joy, the picture there of the Mount Sharp, the tone of the mountain was quite light or whitish, and I don't mean to describe it as snow, but is that an accurate characterization at this stage, and if so, what would that mean?
I actually don't know. The funny thing was I got to work and almost all the scientists had gone to sleep. So I was scrambling to work on this myself. Had some help from image processors, and they were trying to do a lot of stretching, and I believe it was stretched so that you could see a lot in the foreground. And so I wouldn't put a lot of weight yet on the lightness, the tone of the mountain until can get some info from the experts. So I'd be hesitant to say, yes, it looks like snow. I'm not sure. So it probably was stretched that way.
Go ahead.
Good afternoon, good day in Mars. I'm Fernando from Tercer Milenio in Mexico. Then if everything is fine in the Curiosity, when will they start the first experiments? The use of the drill, the laser, the mass spectrometer, the search of the life. When?
Soon. We really need to get to our new version of flight software first. So I would say that's the main constraint we have right now. And it looks like we're on the path to starting that on Sol 5. It takes 2 sols, so Sol 5 and 6 to do the primary computer, and then it takes 2 sols to do the backup computer. So by Sol 9, we'll begin doing the higher level characterizations required to do some of the more exciting science that you're talking about.
Thank you.
Okay, we'll go on the other side of the aisle here.
Hi, I'm Evan Ackerman with IEEE Spectrum. What is going to happen to the MARDI descent imager now? Is it completely finished, or is there anything else you can do with it?
We have plans to try to use it on the surface. Obviously, we can't point it. It goes wherever the rover goes, so and it points down. We have a plan to try to collect a sidewalk size. A field of view is about the size of a sidewalk, and basically drive a sidewalk view of the surface as we drive towards the Mount Sharp. It's a little difficult to do that because it has to be coordinated with the drive. And the drive is a very complicated thing. It has a very exotic cadence. It drives a little, it stops a little, it drives a little bit more. Commanding the camera to do that is very difficult. So we could either have the drive commanded to do that, or we could start the camera and then take pictures while it's driving for the whole amount of time. The problem there is that most of the images won't show any changes because it drives in this sort of stop-start manner. We'd never be able to get all the thumbnails back, let alone full frames. But the intent is to use it. It's got probably, it's nowhere near as high a resolution as the Molly is, but then the Molly's on the arm and doesn't actually look all the time. It's probably comparable to what we could do with the mass cam, but you don't really want to run the mass cam while the vehicle's driving because the focus mechanism, you might damage it, so you want to stow the focus mechanism. So all we could take would be out of focus images. So MARDI has a role, and we're still exploring that.
Okay, we're going to Irene next, and then you, and then we're going to the other side of the room. Go ahead.
Irene Klotz with Reuters for Dr. Crisp. On Earth, typically what is responsible for forming little uniform pebbles and gravel like what you see in this picture?
Good question. I'm going to take a stab at it, and then I'm going to let Mike help me. I would say, did you?
I didn't need to hear the...
Okay, so her question was, on the Earth, what would be a typical way to form this pebbly surface? And I would I'm going to make a
something I know.
guess at it here and just say, we know that Gale Crater was filled in with sediments, and then a large quantity of material has been eroded away. So you're seeing what's left after a lot of erosion, and rock that was once there has been broken up by physical processes, freezing and thawing, and wind, and other ways that it can break it down into little pieces. Now, why it's all these small pieces, I don't know. I think the science team has a lot of work to do to figure out how were these materials put there. You know, was water involved? We don't know yet. Mike, do you want to take a shot at it?
Yeah, this is obviously a lag deposit. That means it came in with a bunch of other stuff, but this stuff is not able to be taken away. The finer materials have been removed from this area. The fact that there aren't a large number of bigger things is more interesting to me than the fact that there isn't a lot of small things. Small things winds can transport. Big things, you have to break them down to get them small, and this is probably potentially impact ejecta, but I'm surprised there aren't larger fragments. This is actually something that me and my team are very interested in, trying to understand what causes this type of surface to develop on Mars. There is a possibility, probably pretty remote, that it's not unlike the materials concentrated at the Meridiani site, in that these may be fragments that were in material above this surface and have been lowered down as that surface was eroded away. And Joy was also alluding to that. So this type of surface is very familiar to people who work in deserts. People go off-road biking and things like that. So this should look pretty familiar to them.
So actually, just on another note, I wanted to clarify something I said about how soon we're going to do things, because I was actually speaking to firing the LIBs and the RMI in the Sol 10-ish time frame. We were speaking earlier about how Curiosity's middle name might be Patience, because it does take time to check out the vehicle, and so drilling is not something that we're going to do until, it may be a month before we're able to drill, because we have to set up the parameters on the arm, we have to deploy the arm, we have 6 sols of checkout of the arm to make sure that we understand how it's behaving in this environment, how it survived the landing. So just didn't want to give you the wrong impression. It's going to take a while before we're ready to drill.
Okay, we'll go ahead over here now.
Hi, Nadia Drake with Science News, and this is for Mike Malin. You might have mentioned this, but I might have missed it, but when are you expecting the high-res video to be ready, and is the thumbnail version posted somewhere that we can see?
Thumbnail what?
Is the thumbnail version posted, and when are you expecting the high-res video to be ready?
The images that I showed will be posted on the JPL website. I believe also the animation will be. The animation itself is actually, I believe, a motion JPEG, so you'll actually have all the frames are combined in that animation. We will get around to doing the raw frames, but we've been going back and forth with JPL about how to get stuff on their cloud server, so that's been an issue for us. They'll be available pretty soon. Now, your earlier question was?
When is the full resolution video going to be available?
Don't know. Right now, we're not really planned to see many of the full frame images till a couple of weeks from now. When we start seeing them, we will get a few full frame images over the next week. There should be one queued up for coming down, I guess, tomorrow morning. Tomorrow morning will be remember the image in the movie, there's a full-up, close-up view of the heat shield, and then the very first frame after that was a little heat shield. That image should be queued up to be coming down first of the full-frame images. Then over the course, I think sometime around Sol 4, we reprioritize the remaining 17 of the first 18, so I expect Sol 5, Sol 6, we might see those. I don't know much about what the downlink for the software load, whatever, the reload, the new load for the software. I don't know exactly what the downlink part of that sol is going to look, those sols are going to look like. But it's in that time frame we'll start getting individual full-resolution images. And one could make an animation probably a much better resolution than this one, just from a few separate full-frame images, because they're 8 times higher spatial resolution than the thing. So it's going to be a couple of weeks before we really start having the pieces for it.
Leo Enright with Irish Television. Curiosity is a word which news reporters understand, but we don't understand patience. So I was just wondering, there was a lot of talk at one stage about an intermission, which seemed to be some sort of a period when you'd actually do some stuff and then get